All right, we'll get going. Today, we want to talk about some strategies for lowering observability costs, and specifically with a focus on OpenTelemetry and how we can use that to build a pipeline and address some of the challenges that so many folks are facing with observability and security costs. So we'll go through a little bit about some of the causes of the rising costs, and then some specific ways we can lower costs with OpenTelemetry, and then strategies you can use when you're deploying this in your environment. And as we're going through that, I'll share some demos and show the practical implementation of some of these cost reduction strategies. First, and I suspect you've run into some of these if you're attending this webinar. There are upfront costs associated with this, and then there are some hidden costs. The really obvious costs that people run into are just an unbounded telemetry growth. And we've seen exponential growth in the amount of data, amount of telemetry that you're ingesting into your observability platforms, your SIMs. And with that, there is typically a direct correlation to the cost. So the more you're ingesting, the more expensive that gets. The second core driver of cost is just the increased complexity of managing. So as this grows, as it scales, and as you're using more and more tools, both to ingest and also to process and analyze the data, the complexity of handling that becomes a significant portion of the cost of telemetry and observability in general. And this was over a year ago now, and I believe it's gone up since then, but just looking at modern workloads. So if you're looking at Kubernetes and others, they're generating petabytes of telemetry. And Gartner estimates that just the management component of that for a very large enterprise can be over 10 million per year. So that's managing all of the agents and the telemetry that you're dealing with, the costs associated with running those. That by itself can get incredibly expensive. What's typically hidden and maybe not as clear are some of these other costs that you'll run into. One is that you have subject matter expertise sprawl. So in a typical environment, as you expand what you're monitoring, you are using different tools, and each of those or each of the platforms requires a level of expertise. And it can be the expertise in managing the agents and how to ingest log telemetry or metric or traces. It can be expertise in using the SDKs or the instrumentation libraries. It can be expertise that's associated with simply the format and how to parse it, how to remove unnecessary fields. So all of that becomes more challenging because you have a team that's trying to manage something that's growing very quickly. It requires a lot of different areas of expertise within that team to manage it and maintain it. There's also a vendor lock-in component. So if you're using proprietary solutions, and sometimes even if you're not, if it's open source, but it's really tied to a specific platform, it makes it incredibly difficult to switch and or even to just try new solutions. And that lock-in can lead to months-long migration efforts, and it can be really challenging to get to a solution, even if you know it may be a better fit for your organization at the time. The last one here is really agent inefficiency at scale. So this is something that, if we're using agents to collect telemetry, if you're using those on a few instances, efficiency doesn't really become a core focus. But if you're doing that, you're deploying multiple agents, and maybe they're not high performance agents, and you're doing that over tens or hundreds of thousands of instances, then this becomes a very real component that needs to be considered when you're looking at costs. This is just a visualization of what that looks like in practice, and really simplified. But if we think about a few hosts and a few applications that are, and we're using different platforms for security, performance management, operations, and maybe some others, the standard deployment model, or maybe the most typical way to start out is to use the tool that platform provides. So if they provide a SDK to instrument your application, you're going to use that SDK, even if it's proprietary. If they, if your APM vendor uses a specific agent, you're going to use that agent as well. But as you start to grow, this becomes more and more of a problem and adds more and more complexity. And if you're looking at a handful of them, it may not be a big challenge. But when you're looking at thousands or tens of thousands, it's clear that this becomes a real pain point, and it needs to be addressed in one way or another to start to standardize and simplify the architecture. And that's what we're going to be talking about, is unifying the telemetry plane. So there's a foundational component, and then what you can do after you've laid that foundation. The foundation is standardizing how you ingest telemetry. And we highly recommend choosing OpenTelemetry for that standardization. But regardless of what you're choosing, standardizing that is really the first step in simplifying things and allowing you to get your entire environment and all of your telemetry under control. So when you standardize, you're going from multiple types of SDKs and agents to a single type that can be used for any platform or any endpoint. And once you're standardized on one agent, one SDK, you can then build out a telemetry pipeline strategy. And just one more data point, in 2022, less than 10% of log telemetry was flowing through a telemetry pipeline. And that's changing very rapidly. The estimate here was 2026, 40% would be processed through a pipeline. And I wouldn't be surprised if it's much higher than that. There's been a lot of movement toward telemetry pipelines. But once you have the foundation in place, there are a lot of additional things you can do to control the telemetry, but it really is based on that foundational component. But we'll talk about some of these, but things like intelligent management of the agents. So if you have a centralized management location for all of those agents, all your telemetry agents, it makes it much easier to identify when you have a problem and how you can address it in real time. If you have this in place, you can also start to reduce or eliminate any unnecessary telemetry. So you can simply filter it out. You can reroute that telemetry to different destinations, including low-cost storage. And you can even store that off to low-cost storage. And then if you do need it in the future, you can rehydrate back into your SIM or your APM. So all of those together really get you pretty far in reducing and optimizing your telemetry plane and reducing costs, both associated with total telemetry volume and also complexity of managing that environment. So just a quick definition of unified telemetry plane, because some of the terms are still a bit in flux, but when we talk about a unified telemetry plane or a unified telemetry platform, it's really a framework that allows you to centrally manage all of your ingestion, all the transformation, enrichment, routing, also reduction of all the telemetry data, and then get that to the correct monitoring, analysis, storage system. So it's really about converting from this, where it's a one-to-one oftentimes, or you're tightly coupled based on the telemetry type and the destination, to something more like this, where you're standardized on a single agent and SDK. You have control of those, and it's all flowing through a single pipeline. And this may be scaled out. This is a simple version. The idea is that it's all standard in the way that you're implementing that pipeline. Let's talk about how we lower costs with OpenTelemetry. I won't spend too much time on this because I think most folks are familiar with it, but the refresher is OpenTelemetry is more than just a collector. right? That's a key component. The OTel collector, vendor agnostic, supports traces, metrics, logs, can be deployed in nearly any environment that you can think of. Supports a wide range of operating systems, deployed in Kubernetes, on-prem in the cloud, and manages really all telemetry types. And this can handle and can replace a lot of agents that you would have currently, whether it's proprietary or open source. And then the other components of it are protocols. This is where it's the definition of the data as it flows through your pipeline. This is important because you need a standard. This standard, if you don't have it or if you're using multiple protocols, really increases the complexity on your team. It requires a lot of additional subject matter expertise to manage that and control the flow of that. And then there's an instrumentation component. This is, SDKs for instrumenting your custom applications, typically used for traces, but a full instrumentation library for different languages, both manual instrumentation and then auto instrumentation. And so this suite really covers everything that you need for telemetry, ingestion, processing, and transmission. So how does it actually reduce your costs by switching to that? There are a few ways, and we talked about standardization a bit already. So by standardizing this, whether it's the agent, the protocol, the spec, this allows a single set of resources that you're managing, that you're responsible for, as opposed to what could be 5, 10, 20 different types that you have to learn and then manage in separate ways. So standardization reduces complexity, which reduces cost. Centralization is the next component. With OpenTelemetry, OpenTelemetry supports OpAmp. It's a remote management protocol that allows you to manage those telemetry agents from a single place and manage them all as a fleet of agents, as opposed to managing individual configuration files on all of the specific collectors or integrations. And then we already mentioned vendor neutrality. That's a key component. A lot of it can come down to switching costs, but it's also just simply a matter of allowing you to use a single tool for everything and not being locked into a single vendor for one pipeline. To talk about standardization, it's consolidating tools, it focuses your subject matter expertise, simplifies support maintenance, and really facilitates centralized management. So if you have standardization at the agent level, you're able to manage that all in a central location. We'll see why that's key in a minute. And centralization, it creates actionability. So it can be really difficult, even if there is an issue, or if you identify that my costs in a certain solution are growing far too quickly or are much too high. It's not easy to diagnose where that issue is. And if you have a centralized area where you're managing that, monitoring it, it allows you to take quick action and to find out where that specific point is and what your options are for reducing. It's also a prerequisite for being vendor agnostic. And management, when we get to scale, it becomes more and more critical to have something central managing all of your telemetry agents. Already talked a bit about vendor neutrality, but if you think about this long term, that's really the primary driver for it. It's long-term cost reduction, allows you to migrate easily, allows standardization on a single solution, and you can't do that if you're locked into a specific vendor component or vendor pipeline. So that was on the switching to OpenTelemetry in general, but there's another component which is really, what do you do once you have this in place? And that's when we start to think about routing, aggregation, and processing. And routing is just allowing you to easily take any of that telemetry of any type and route it to the correct destination and reroute it elsewhere when you need to. That's something that's not not easy in the old way of doing things, but is much, much simpler with OpenTelemetry in a pipeline. The aggregation component is the ability to scale and to aggregate data from many sources, but to support high volumes of data. And so as your environment gets very large, this is a critical component of that. And processing. So processing, filtering, elimination, reduction, these are all talking about the same things. OpenTelemetry, even within the official project, supports dozens of processors. And they're focused on things like transforming data, eliminating unneeded data, enhancing that, filtering out components that you may not need. And again, I'll show a couple examples of this as well. But those are the two key levers that we have. One is, once we have the pipeline in place, how do we route and process that data in the best way possible? And then prior to that, what are the benefits of getting it in place to just simplify and reduce the complexity that allows you to get to this point? So we'll go through a couple of strategies and also some demos. Just one more look at the ideal state. And typically what we want to get to is, in a very large environment, you have your agents. These are deployed at the edge. They may be on a host. They may be in a Kubernetes node. It would include or could include an SDK that's instrumenting your applications. But these are all transmitting to a gateway group. So depending on the scale, depending on the throughput, this may be many collectors, but it allows you to handle processing separate from the edge node. And then it goes from the group to the destination. This can be broken down by region, can be broken down by app, could be based on teams. That's really based on the business needs. But if you think about what's the ideal architecture, it looks something like this. One thing to note is that with OpenTelemetry, the collector in agent mode is identical to the collector in a gateway mode. So you're dealing with the same binaries, the same configuration, the same. Once you understand one, you understand them both. So there's your ideal state. Now, how does it play out when you have a situation? So let's assume that we have a simple environment. We have an orchestration component. We have instrumented our hosts and applications with OpenTelemetry, and we're sending them to a gateway, and then that data is flowing to two destinations. We have a SIEM and an APM platform. So whereas before, if you notice that costs were getting out of control, it might be challenging to identify and determine what was going on. But just to give you an example, a real world example, I'm going to jump over to bind plane. And this is a high level overview of an environment with 1,000 agents. These are all OpenTelemetry agents that we're managing. And we're sending to multiple destinations here. You can see that we have logs, metrics, and traces are all running, and they're grouped into fleets, so we can share configuration across all of these agents. But you can see that this is in place. So now we have the orchestration layer that's bind plane, and it's managing this fleet of 1,000 agents. So when I determine that there's an issue, I might hear and say, there seems to be a lot of data flowing in this one location, and I'm not expecting, or maybe I saw some cost increases. We can also use this view and look at what my data what my summary is. So I can see that with this particular destination with Grafana, I'm not reducing any of the data as it's flowing through the pipeline. And we can choose that by any of the destinations, and can see that, well, we should have a target of reduction, because typically there's a lot of additional information in that telemetry that's not necessary and not needed in the final destination. So I'm going to look at a specific instance here as an example. And this one roughly replicates what you're seeing in this view. We can say we have a SIM, we have an APM. Maybe we're sending more than we're expecting, and thinking maybe an opportunity for a reduction. In this case, we're gathering metrics and logs from standard host metrics, some Windows logs and Windows events are all being transmitted. So we take a look at this and say, what is the first step? When we have this layer, we can consider filtering out data that's not needed at the edge or at the gateway before it's ever sent to either destination. And so to do that in BindPlane, we can do a couple things, but to give you a sense of what this looks like, if we go into one of these processors, these are managing OpenTelemetry collectors. So I'll show the raw configuration after, but everything that we're doing now, you can do within an OpenTelemetry collector. BindPlane provides recommendations. So it says, recommends deleting empty values. That would reduce the total logs by almost 10%. And this is just null values, empty values. So we can safely do that. We can safely accept that. And then we'll see that there's a reduction in the total volume of those logs. But we're going to do something more powerful. And here are a few processors that are available. Some of the strategies depend on your specific workload type, but we can convert logs to metrics. We can do counts, deduplicate, delete values like you saw, filter out specific items, do things like filter out severity, masking data, and even sampling, do sampling on logs or metrics or traces. And we can apply that all in real time. But for now, I'm going to filter by severity. I'm going to say that for Splunk, I really only want to see the warning level or higher logs. And so when I add that processor, I'll see the change from 125 log lines in the sample to 23 after. I can push that out. That was, a simple example of one of the ways. Now we can go through and apply that specifically on each of the workloads and see what recommendations are available at each point. But for the data flowing, in this case, that would have been flowing to Splunk, we're now going to eliminate all of those warning log lines. That'll reduce this significantly. We'll give it a second to populate with the latest data. Look at the next one. So we added in some filtering. You can see it reduces some of the data, reduces it coming from the host, reduces what we're sending to the destination. But then another strategy that is very effective. And one thing that we see is, it can be challenging to determine what you need or what you can filter out without impacting visibility in the long term. And so sometimes as a strategy, we'll see customers send and reroute the full fidelity data to low-cost cloud storage. And then you can feel more comfortable sending that telemetry to the reduced telemetry to the destination. So if you need it for compliance, if you need to potentially investigate an incident later on, you have the data in a bucket. Maybe it's an S3 or Google Cloud or Azure, but it's a very low cost solution, and then it can be rehydrated using BindPlane or with some configuration through OpenTelemetry. And to give you an example of that, and we see the reduction took effect. So we see a significant drop from 2 megabytes per minute to under, it's 300K per minute. But now let's do something even more significant with this. And we could say, we want to, in this case, we'll add in a different destination. So I had a Google Cloud bucket. And now what we're doing is we're rerouting everything to also send to Google Cloud. And I'll add in those same filters I did before. send this. And now what we've done is we've had about an 80% impact or reduction in the total volume of data that's being sent to Splunk and New Relic in this case, but we're still maintaining a full fidelity copy of that in GCP. So if we need to pull that back in and investigate a specific incident, we can do that. And so it allows you to really dramatically reduce the volume of data and the cost, while still having confidence that if you need that information for compliance or otherwise, it's still available to you. So we'll jump back in and just go through a couple of other options within Biplane. Sending to low-cost storage, we can see now we're sending majority of the data to GCP. In a moment, it'll all shift over. That gives you flexibility in where you store the data. Then you can also build solutions from here to rehydrate and pull the data back out of GCP, maybe rehydrate it into Splunk or New Relic or another destination. But wanted to show you that underneath all of this is just OpenTelemetry. So this is a raw OpenTelemetry configuration that's being applied. And so you can see we're collecting host metrics. We're gathering IIS logs. We have Windows event log sources as well. And then the processors that we're implementing are also visible. So everything that we did in there can be implemented within a configuration file. It just gets more complex to do by hand. And then even the outputs to GCP, to New Relic, and others are going to be available and visible within this configuration. So now we have it in the final state. We have this sending reduced volume to Splunk, reduced volume to New Relic, and then sending the full fidelity to GCP. And that's really the first step in using a telemetry platform once you have it in place. But from here, you can really do so much. You have so much flexibility. There are many other options for reducing. In this case, we're sending it directly to these destinations. We can reroute this and send it instead to a gateway. So gateway is available here. Choose this. And this would replicate more closely what you're seeing here. Going from a collector to a gateway and then to the end destination. And that can all be done with a few clicks. So that's the quick overview of the key areas where you can reduce costs with OpenTelemetry and Biplane. Biplane, has native support for OpenTelemetry. It also has native support for OPAMP, the remote management protocol for OpenTelemetry. We have our own ObservIQ OpenTelemetry distro, and within the next month or so, we'll be supporting a bring your own distribution of OpenTelemetry. So you can use your own build, and you're not required to use an ObservIQ OpenTelemetry distro, but really designed to manage your environment at scale. So when you're talking about thousands or tens of thousands of agents and really massive amounts of telemetry, many destinations, Biplane is a great solution for your environment. So we have a couple of resources that we can send out after. If you're looking for more information on constructing an observability pipeline, we go into more detail on how to do that in a previous OTel series webinar that's available on our site. And we also have a webinar on managing high volumes with OpenTelemetry, which can be really helpful as you're looking to scale. We also have a Gartner report that we took some of those metrics from and quotes from. It's available on our site. That's it for me. Any questions before we wrap up for today? All right. Well, if not, thanks so much, and have a great rest of your day.